So today let's discuss questions asked in 2025 on topic calculus. So there were in total 6 questions asked on this topic. So let's see them one by one. So the question 1 says that a rectangular sheet of metal of length 6 meter and width 2 meter is given. So they have given us a rectangular sheet of length 6 meter and its width is basically 2 meter. And it further says that 4 equal squares are removed from the 4 corners. And let's just draw the figure and see it side by side. So for example, if this is my rectangular sheet and its length is given to me as 6 meters while its width is 2 meters. It says that 4 equal squares are removed from each corner. So let's assume that let x be length of side of square removed from each corner. Removed from each corner. So if it is removed from each corner, so this length must be x. Likewise, this length also be x. Similarly, we have removed these squares from each side like this. So if I calculate length of basically remaining sheet, so it will be basically 6 minus 2x, this length, and its width will be basically 2 minus 2x, because this length is x, this length is x, and this length is also x, and this whole length is 2. So 2 minus x plus x. So we got 2 minus 2x. Likewise, length we got as 6 minus 2x. So it further says that the sides of this sheet are now folded up to form an open rectangular box. So these sides are formed folded up like this, from here and from here and from here, to form a rectangular box basically. So we are supposed to approximate the height of a box such that the volume of box is maximum. So we are supposed to find this length x, because this length x will be height of the rectangular box. So this length x is such that the volume of the rectangular box that is formed post folding the sides is maximum. So let's see what will be the volume of the rectangular box. So volume of a rectangular box will be equals to, volume is basically length, width into height. So length is 6 minus 2x, width is 2 minus 2x, and height is x. So if I simplify it, it will be, or let's just leave it here and let's denote it with v. So v is our volume and we need to find value of x such that this volume is maximum. So first let's just calculate its derivative with respect to x. So it will be 6 minus 2x into 2 minus 2x plus x into 6 minus 2x into minus 2 plus x into 2 minus 2x into minus 2. And if we simplify it, let's just calculate its second derivative here only, so that we don't need to calculate it again. So d square v by dx square will be minus 2 into 2 minus 2x minus 2 into 6 minus 2x minus 2 into 6 minus 2x and minus 2x into minus 2 plus, or it's minus only, minus 2 into 2 minus 2x and minus 2x into minus 2. Now if I simplify its double derivative, it will be, I can club in these two terms, it will be minus 4 into 2 minus 2x. Likewise, I can club in these two terms, minus 4 into 6 minus 2x, and these two terms that give me 4x plus 4x, that is 8x. And it can be further simplified as minus 8 plus 4 to the 8x minus 6 4 is 24 plus 4 to the 8x plus 8x, that is equals to 24x minus 32. Now let's find out the point x by equating the first partial derivative with respect to x, that is equating dv by dx equals to 0, because this will give us the critical points where the function fx can attain maxima, or where the function v can attain maxima or minimum volume. So if I equate it, it will be 6 minus 2x into 2 minus 2x and minus 2x into 6 minus 2x plus 2 minus 2x equals to 0. And if I simplify it, it will give me 6 2s are 12 minus 4x minus 6 2s are 12x plus 4x square minus 12x plus 2 2s are 4x square minus 2 2s are 4x plus 4x square equals to 0. Now let's just club in the common terms. So from here I'll get 4x square plus 4x square plus 4x square. So that is 12x square, and further we have minus 16x, 28 and minus 4. So it is minus 32x plus 12 equals to 0. Now I can divide by 4 throughout, so it will give me 3x square minus 8x plus 3 equals to 0. So we got a quadratic equation in x, so we can solve it simply for x. So x will be equals to 8 plus minus under root b square, that is minus 8a square minus 4 into a into c divided by 2 times of a. So my x is equals to 8 plus minus under root 64 minus 4 3s are 12 and 12 3s are 36 divided by 6, that is equals to 8 plus minus 64 minus 36 is basically 28 divided by 6, and I can write 28 as 7 times 4. So it will be 8 plus minus 2 root 7 by 6. So from here x is equals to 4 plus minus root 7 by 3. So I got these two values of x, and I need to check like for which value of x my double derivative with respect to x is giving minimum and maximum. So d square v by dx square at x equals to 4 plus root 7 by 3 will be equals to 24 into x, that is 4 plus root 7 by 3 minus 32. So it is equals to 8 4s are 32 plus 8 root 7 minus 32. So it is equals to 8 under root 7, which is greater than 0, and at another point d square v by dx square at x equals to 4 minus root 7 by 3 will be equals to 24 times 4 minus root 7 by 3 minus 32. So it is 32 minus 8 root 7 minus 32. So it is equals to minus 8 root 7, which is less than 0. So we like at this point, since it is greater than 0, the volume will be minimum. And since d square v by dx square at this point turns out to be less than 0, so here volume will turn out to be maximum. So we are supposed to find the length x such that the volume is maximum. So the length or volume of box is maximum when x is equals to 4 minus root 7 by 3. Either you can leave it here as well, or you can just use the calculator to find it out in decimal forms. So you can do that yourself. So let's move on to the next question. So the next question says that they have given us a function f that satisfies this relation. So the relation is f of x plus y is equals to fx times fy, and it holds for all xy belongs to real number. And it further says that fx is not equals to 0 for any real x. That is, fx is not equals to 0 for all x belongs to real number. And another information is f dash 0, that is derivative of f at 0 is basically equals to 2. So our claim is, that is, we need to show that for all x belongs to real number, f dash x is equals to 2 times fx. This is we are supposed to prove, and we are also supposed to find a function fx later on. And like, this question is a repeated question, it's asked twice. This is the third time it's being asked in this examination. It was earlier asked in somewhere around 2008 or 2009. So let's move on to see this question. So we are supposed to prove that derivative of f is equals to 2 times fx. So derivative of f at any point x is basically equals to limit h approaches 0, fx plus h minus fx divided by x plus h minus x. We got this using definition of derivative. Using definition of differentiation. Now in the question it is given that f of x plus y is equals to fx times fy. So if we use that relation here for fx plus h, so it will be limit h approaches 0, fx times fh minus fx divided by h. Now if you see that the limit is on h, so we can pull this fx out, so it will be equals to limit h approaches 0, fx multiplied by fh minus 1 divided by h. So it is equals to fx times limit h approaches 0, fh minus 1 divided by h. Now if you observe that they have given us a relation that says that fx plus y is equals to fx times fy. Now if I take my both x and y is equals to 0, so this will give me f0 plus 0 equals to f0 times f0. That is, I can write it as f0 equals to f0 whole square. Now from here I can conclude that either my f of 0 is equals to 0 or my f of 0 is equals to 1. But if you remember that in the question they have said that fx is not equals to 0 for any value, any real value of x. So f of 0 is also a real number, so f of 0 cannot be 0, so we can discard this option. So from here we got that value of f of 0 is equals to 1. Now if I plug in this value of f of 0 in the last equation that we got, so it will be f dash x is equals to fx times limit h approaches 0, fh minus 1, so in place of 1 I am writing f0 divided by h. Now if you observe that this is basically what is definition of f dash 0. Like if in the previous definition, like herein if I put x equals to 0, so I'll get exactly this. So it is equals to fx times f dash 0, and in the question they have given us that f dash 0 is basically equals to 2. So from here I got f dash x equals to 2 times fx. So this is the relation we are supposed to prove. Also observe that initially we have observed that x is any arbitrary real. So since we have proved it for any arbitrary real, so it's true for all x in real number. Now we are supposed to find in the value of function fx. So from here I can write it as f dash x by fx equals to 2, and which further can be written as d of fx divided by fx is equals to 2. Now if I integrate on both the sides, I'll get integration d of fx by fx equals to integration, or I can write it as, I can write it as d of fx with respect to x divided by fx equals to 2. So from here I can write it as d of fx by fx equals to 2 times dx. Now I can integrate on both the sides, so I'll get log of fx equals to 2x and plus c, where c is a integration constant. So from here my fx will be equals to e raised 2x plus c, which I can write it as e raised 2x times e raised c. Now I can assume that e raised c is basically a constant because c is a constant. So I can assume that e raised c is equals to a, let's say. So from here my fx will be equals to a times e raised 2x. Now if you see that we have calculated that f of 0 is equals to 1. So if I plug in x equals to 0 in this equation, so this will give me f0 is equals to a times e raised 0, and e raised 0 is 1. So from here I got a is equals to 1. So from here I got my function fx as e raised 2x, and this is what we are supposed to find. We are supposed to calculate the function fx, and it turned out to be equals to 2x. So let's see next question. So this question says that using mean value theorem, prove this relation. The question itself, in the question itself, they have specified that we are supposed to use intermediate mean value theorem. So let's do this. So first let's just simplify this relation and see what we get. So it is given to us as that sine inverse 3 by 5 is less than equals to pi by 6 plus 1 by 8 and greater than equals to pi by 6 plus under root 3 by 15. So from here I will get under root 3 by 15 less than equals to sine inverse 3 by 5. Basically I subtracted pi by 6 throughout, so it will be 3 by 5 minus pi by 6 less than 1 by 8. Now this can be simplified as under root 3 divided by 15, I can write as 5 times 3 less than equals to sine inverse 3 by 5, and pi by 6 is basically sine inverse 1 by 2, which is less than 1 by 8. Now it simplifies to 1 by 5 under root 3 less than equals to sine inverse 3 by 5 minus sine inverse 1 by 2 less than equals to 1 by 8. Now let's just name this relation as relation 1 for time being, and let's assume that fx equals to sine inverse x. We know that this function is basically is continuous and differentiable on interval like 1 by 2 comma 3 by 5, close interval, and open interval 1 by 2 comma 3 by 5 respectively. And we got these intervals from this relation because this is what intermediate value theorem states, that for any function fx which is continuous, for any function fx which is continuous on closed interval a comma b and differentiable on open interval a comma b, then there exists a c in open interval a comma b such that f dash c is basically equals to fb minus fa divided by b minus a. So we got this interval using this relation, that is equation number 1. So let's see. So since the function fx, that is sine inverse x, is basically satisfying all the necessary condition to apply mean value theorem, so using that there must exist a c in open interval 1/2, 3/5 such that f dash c is equals to fb minus fa divided by b minus a. Now in our case my b is 3/5 and a is 1/2. So from here my f dash c will be equals to sine inverse 3/5 minus sine inverse 1/2 divided by 3/5 minus 1/2. And the function fx is sine inverse x and its derivative is basically equals to 1 by under root 1 minus x square, and since we are calculating it at point C, so it will be 1 divided by under root 1 minus c square. So it must be equals to sine inverse 3/5 minus sine inverse 1/2 divided by, it will be 6 minus 5, that is 1/10. Now we need to show that this term basically lies in between 1/5 root 3 and 1/8. So first let's see, in order to show that, first let's see in what interval this belongs. So if you observe that, we know that our c belongs to, c is less than 3/5 and greater than 1/2. So from here I can say that basically c square will lie in between 9/25 to 1/4. Now if I multiply it by 1 on both the side throughout, so it will be minus 1/4 greater than minus c square greater than minus 9/25. Now I can just add in 1 throughout, so it will be 1 minus 1/4 greater than 1 minus c square greater than 1 minus 9/25. So it simplifies to 3/4 greater than 1 minus c square greater than 25 minus 9 is basically 16/25. And if I take its under root, so it will basically be equals to under root 3/2 greater than 1 minus c square and greater than 4/5. Now from here if I calculate bounds of 1 by under root 1 minus c square, so it will be equals to, it will be basically less than 5/4 and it will be greater than 2 by root 3. Now since this term is basically equals to sine inverse 3/5 minus sine inverse 1/2 divided by 1/10, so I can just plug in the value. So it will be 2 by root 3 less than sine inverse 3/5 minus sine inverse 1/2 divided by 1/10, and it is less than 5/4. Now if I just multiply by 1/10 throughout, so it will give me 1/5 root 3 less than sine inverse 3/5 minus sine inverse 1/2 less than 1/8. Now I can just plug in the value of basically sine inverse 1/2, that is pi/6. So if I do so, I'll get 1/5 root 3 less than sine inverse 3/5 minus pi/6 less than 1/8. Now I can just add in pi/6 throughout. Also I can just multiply and divide by root 3, so it will be under root 3/15 plus pi/6 less than sine inverse 3/5 less than pi/6 plus 1/8. And this is the relation that we are supposed to basically prove in this question. So now let's move on to see the next question. So the next question says that evaluate this double integration where R is region bounded by y equals to x and y equals to 4x minus x square. So first region is basically a line at 45 degrees and second is basically a equation of a parabola. So first let's just see the diagram and then we'll just solve it. So if this is my y-axis and this is my x-axis, so that this line, that is y equals to x, is this line, and the parabola is basically passing by a 0, 0. Also you can just reduce it in a more simplified form, so it will be y equals to, you can pull out minus, so it will be x square minus 4x, and you can just add and subtract 4, so it will be equals to y equals to minus x minus 2 square plus 4. So this is basically more simplified form, and if you'll just draw its figures, so it will be somewhat like this. So we are supposed to evaluate this over region R, where R is bounded by these two curves. So basically our region R is this shaded region that I am shading with pink colored pen. So now let's find out the intersection point. So one point is 0, 0. We need to get in the other point as well in order to know the limits of integration. So let's just, since they are intersecting, so the two values of y must be equal. So if I just equate it, so it will be x equals to 4x minus x square. So from here I'll get x square equals to 3x. So this basically gives me x equals to 0 or x is equals to 3. Now when x is 0, y is also 0 because y is equals to x, and when my x is equals to 3, so y is also equals to 3. So the another point is basically 3, 3. Now let's just integrate, like find in the double integration. So it will be equals to double integration over region R, that is the region shaded with pink colored pen, into y into dx dy. Now x varies from 0 till 3, or maybe let's just evaluate it with respect to y first. So it will be y dy times dx. So y varies from x to 4x minus x square, and x varies from 0 to 3. So if we just solve it, it will be integration from 0 to 3. Let's just integrate it first with respect to y. So it will be y square by 2, and limit varies from x to 4x minus x square dx. Now this 1 by 2 is constant, so I can just pull it outside the integration sign. So it will be integration from 0 to 3, 4x minus x square whole square minus x square dx. Now if I just simplify it, it will be 1 by 2 times integration from 0 to 3, 16x square plus x raised 4 minus 8x cube minus x square dx. It simplifies to 1 by 2 integration from 0 to 3, 16x square minus x square is 15x square minus 8x cube plus x raised 4 times dx. Now if I integrate it, it will be 1 by 2 15x cube by 3 minus 8x4 by 4 plus x raised 5 by 5, and limit varies from 0 to 3. And if I simplify it, it will be 1 by 2 times 5x cube minus 2x raised 4 plus x raised 5 by 5. So its final value is 1 by 2 5 into 3 cube, that is 27, minus 2 into 3 raised 4, that is 81, plus 3 raised 5 by 5. So this is the final value, and you can just simplify it to get the answer. Square units. So let's move on to see the next question. In the next question, they have given us a function u, that is x times fy by x and g times gy by x, where f and g are basically arbitrary function, and we are supposed to show these relations. Now if you observe that, just observe the left hand side of both the function 1 and function 2, then you can recall that these are basically related to Euler's theorem. This one is Euler's, somewhat related to Euler's first theorem, and likewise this one is somewhat related to Euler's second theorem. So first let's just see what Euler's first theorem and Euler's second theorem says. So Euler's first theorem says that if u is any homogeneous function of degree n, then x del u by del x plus y del u by del y is equals to n times x. And likewise Euler's second theorem states that if u is any homogeneous function of degree n, then x square del square u by del x square plus y square del square u by del y square plus 2xy times del square u by del x del y is equals to n minus 1 times u. So these are the Euler's first and Euler's second theorem, and we have seen proof of these two theorems in the previous videos, so you can check them out there. Now we are supposed to prove in this relation. So first let's just see how we can prove the first relation. Now the given function u to us is, we are proving first. So u x comma y is basically given to us as x times fy by x plus g y by x. Now I can write it as u plus basically v plus w, v x comma y plus w x comma y, where v x comma y is basically homogeneous function of degree 1 and w x comma y is homogeneous function of degree 0. Now if we just apply Euler's first theorem separately on the function v and function w, so using Euler's first theorem on v and w separately, so we'll get x times del v by del x plus y times del v by del y equals to n, that is degree of function v, which is 1 times v. Likewise if we apply it on w, so we'll get x del w by del x plus y del w by del y equals to n, that is degree of w function, which is 0 times w, that is 0 only, and this is equals to 1. Now if I name them as star 1 and star 2, now let's just add in both star 1 and star 2, so I'll get x times del v by del x plus y times del v by del y plus x times del w by del x plus y times del w by del y equals to v plus 0, that is v only. Now I can just club in these two terms, so I'll get x times del v by del x plus del w by del x plus y times del v by del y plus del w by del y equals to v. Now this can also be written as x times del by del x v plus w plus y times del by del y v plus w equals to v, and v plus w is basically equals to u, so this simplifies to x times del u by del x plus y times del u by del y equals to v, and v is basically equals to x f y by x. And this is what we are supposed to prove in the first relation. Now let's just prove the second relation. Now likewise, if we apply just Euler's second theorem on the function u and v separately, so we'll get x square del square v by del x square plus y square del square v by del y square plus 2xy del square v by del x del y equals to n, that is 1 into 1 minus 1 times v, which is 0 only. Likewise, if we apply it on w as well, so we'll get x square into del square w by del x square plus y square into del square w by del y square plus 2xy into del square w by del x del y equals to n into n minus 1 times w, but our n for function w is 0, so it is also 0. Now we can just add in these two terms, so we'll get x square into, like we can club these two together, so it will be x square into del square v by del x square plus del square w by del x square plus y square into del square v by del y square plus del square w by del y square plus 2xy into del square v by del x del y plus del square w by del x del y equals to 0. And these terms can be written as x square times del square by del x square into v plus w plus y square into del square by del y square of v plus w plus 2xy into del square by del x del y v plus w equals to 0. And our v plus w is basically u, so it can be simplified as x square into del square by del x square u plus y square into del square u by del y square plus 2xy into del square u by del x del y equals to 0. So this is the final relation that we are supposed to prove in relation number 2. So this completes this question. So let's move on to see the next question. So the next question says that they have given us a function in two variables defined as this, and we are supposed to find in fxy 0, 0 and fyx 0, 0. So let's just find out this. So first let's just find out first order derivative of fx with respect to f with respect to x at 0, 0. So it will be equals to limit h approaches 0 fh, 0 minus f0, 0 divided by h, and it will be equals to limit h approaches 0 fh, 0 will be basically 0 only, and f0, 0 is 0, so it is 0 only. Likewise, f first order derivative of f with respect to y at 0, 0 will be limit k approaches 0 f0, k minus f0, 0 divided by k, so it will be equals to limit k approaches 0 f0, k will be 0 only, so it is 0 minus 0 by k, that is 0 only. So now let's just find out h, like fy, x at 0, 0, which is basically derivative of fy at 0, 0. So it will be equals to limit, it's opposite, so it is this, so it will be equals to basically limit h approaches 0, fy h comma 0 minus fy 0 comma 0 divided by h. Now we have this value, that is fy 0 comma 0, but we need to find in this value, so basically this value. So let's just find out that first. So fy h comma 0 will be equals to limit k approaches 0, f h comma k minus f h comma 0 divided by h. So it will be equals to limit k approaches 0, f h comma k will be hk, h square minus k square divided by h square plus k square minus 0 divided by h. And if we take limit k approaches 0, like this, h balances this, so it will be equals to limit k approaches 0, k times h square minus k square by h square plus k square, so it is equals to 0 only. So fy comma x 0 comma 0 is equals to 0 minus 0 by h, which is 0 only. Now let's just find out fxy at 0 comma 0. So it will be equals to limit k approaches 0, fx 0 comma k minus fx 0 comma 0 divided by k. We know this value, but we need to find in this value, that is fx 0 comma k. So let's just find it out. So fx 0 comma k will be equals to limit h approaches 0, f h comma k minus f 0 comma k divided by h, and it will be equals to limit h approaches 0, f hk will be hk, h square minus k square divided by h square plus k square minus f 0 comma k will be 0 only divided by h. Now if I just okay, we have done a calculation mistake herein. So it will be equals to, here we'll have k, so it will be equals to limit k approaches 0, fhk will be hk, h square minus k square divided by h square plus k square minus 0 divided by k, and this k balances this, and if we simplify it is equals to h. So the limit results out, so the limit will be equals to h minus 0, and here limit h approaches 0, so this limit turns out to be equals to 1. Likewise, this limit will be equals to limit h approaches 0, k times h square minus k square by h square plus k square, so this turns out to be minus of k. So fx comma y at 0 comma 0 will be equals to limit k approaches 0, fx at 0 comma k is basically minus k, minus fx 0 comma 0 is 0 divided by k, so this is equals to minus of 1. So we got fxy 0 comma 0 as minus 1 and fyx at 0 comma 0 as 1. So this is the final question. So like if you see that the questions were on repeated format only, like these similar questions on similar patterns were asked in previous years as well. So if you can, if you are comfortable with just solving the previous year, so you are on a good track. So thank you for watching, and please do like, share and subscribe the channel.